Good morning, evening, or mid-afternoon, everybody. My name is Gentry, and I am an instructor and researcher in computer science. This is Single Star Software, the channel where I ramble about Python and occasionally forget core features of the language. We've been letting our focus on machine learning guide our understanding of the Python language, right? Guide our learning of the Python language. So before you continue watching this video, you should have an understanding of the basic syntax of Python, including variables, operations, I/O, that's input and output, branching, looping, functions, and classes, right? So if any of that sounds kind of unfamiliar to you, circle back to the first two videos and review that basic syntax of Python. So today we're going to shift our focus away from the core language Python and over to artificial intelligence and machine learning, right? What are they and how are they related? So we're going to learn the three fundamental tasks of machine learning. And we're going to discuss the two main packages for implementing neural machine learning models in Python. Those are TensorFlow and PyTorch. Artificial intelligence is usually portrayed as machines being able to engage in conversation and plot against humanity. But when computer scientists use the phrase, we're talking about writing programs that can make decisions based on some input. So we might ask a computer to identify healthy produce, or to spot grammatically correct sentences. And either one of those can be done without making a computer that can have a conversation or blot out the sun to starve humanity. Machine learning is one technique in the broader field of artificial intelligence. Machine learning allows computers to guess solutions to some problems and then update the program by making those guesses, update the program that is making those guesses by measuring how close they were to being right. So if we ask a computer which of these are dogs and which of these are cats, it would start by making some guesses almost completely at random, right? And then we would correct it, right? We would correct its guessing algorithm to eventually get it a little bit closer at a time to making correct predictions. And I hope that these look a little bit like cats. Drawing cats seems to be difficulty for me, right? So it may not be exactly right every time because machine learning lets us sacrifice a little bit of accuracy in order to solve problems that weren't easily solved by traditional computer algorithms. In video 2, we talked about functions as being groups of instructions that can be simplified or abstracted by discussing them in terms of their inputs and outputs. We pass in arguments and we get back return values. So once we understand functions in these terms, we can kind of forget about the instructions that make up those functions. The function just becomes a relationship between some numerical values. So data goes in and information comes out. Machine learning models also learn relationships between data and information. But unlike precise functions, machine learning permits a little bit of uncertainty. In that relationship. So that's why we call machine learning a tool for function approximation. We know that the relationship exists, but we can't perfectly capture it, right? Instead, we can approximate it by minimizing the loss, which is a measure of the incorrectness of the output. There are three kinds of relationships that we can learn using machine learning, or three tasks that we can do. The first task is classification. or learning a relationship between data and a label of that data. So we might ask a robot to look at these pictures and pick which of them are cats and which ones are dogs. The second task is regression, and that means looking at a sequence of numbers and picking the next value in that sequence. If we taught a robot to watch a month of temperatures and then predict what the next day's temperature is going to be, it would be doing a regression. The third task is clustering, which means putting data into groups that maximize the similarity of those groups. Clustering is an example of unsupervised learning, which means we don't have any pre-existing right answers. And so we leave it up to the machine to best approximate this kind of relationship. So let's say that we have some data on two axes. Maybe these are those tomatoes that we saw earlier. So one axis would be the weight of the tomatoes, and one axis could be how red they are. So we have some pre-existing information about old tomatoes. We know which ones were accepted to be sold in the produce aisle and which ones were rejected or like made into sauce. So the X's were rejected and the circles made the cut. So what if a new tomato comes in? Let's say like right here on the plot. So how do we know if it should be accepted or rejected? We need to know what region of this graph is acceptable to be sold as produce and what region of this graph should be rejected and sent to the sauce plant. If we draw a curve between the X's and O's, we've created what's called a decision boundary. Everything on this side of the boundary will be accepted as a good tomato, and everything on this side of the boundary is going to be rejected as a bad tomato. So we can see that our test sample here, right now we know that it is on the good side of the decision boundary here. Classification is all about finding decision boundaries in our data, and with machine learning we can learn to define some very strangely shaped decision boundaries. There are 3 packages for the Python language that make machine learning easy, or like doable at least. Scikit-learn gives us a wide range of tools for creating older but still very useful models, and some great tools for like measuring the performance of models or measuring the distance between 2 points of data. Scikit-learn has a lot of great tools packed into it. The newer approach to machine learning is mostly based on neural models. Right, and there are 2 packages for doing that. One, TensorFlow, is owned by Google, and the other, PyTorch, is owned by Meta, or the company currently known as Meta. Neither is really better, but for these videos we're going to be using TensorFlow because it's a little bit more user-friendly for people starting out. So don't worry about what a neural model is right now. We're going to be getting into that in a later video, right? So for now, start looking up TensorFlow, start seeing what it takes to install that package on your computer. And for now, thank you so much for watching. Please subscribe to stay up to date with our newer videos as they're released. Come back in about 2 weeks when we'll be installing Scikit-learn and coding up our first model. I'm sincerely open to feedback, so please like the video if you appreciate what I'm doing, and leave a comment with your feedback if you have any requests for future videos. See y'all in the next one.